All right, we've got two more theorems left. So, theorem 3.11 is the perpendicular transversal theorem. So, we talked about transversals for most of this chapter. You have a picture here of a transversal. This says that if a transversal is perpendicular to one of the two parallel lines, then it is perpendicular to the other. So what does this mean? This means that if we have a transversal that has two parallel lines, H and K have to be parallel, and the transversal, J, is perpendicular to one of them, then that means that you can establish that this one is also perpendicular, that J is also perpendicular to K. So we'd say if H is parallel to K, and J is perpendicular to H, then J is perpendicular to K. All right, last one. Theorem 3.12, and this is the lines perpendicular to a transversal theorem. So this is very similar. It's kind of just the flip side. In a plane, so we're working in a plane here. If two lines are perpendicular, to the same line, then they are parallel to each other. So this is saying that in a transversal, let's look in a plane, two lines, M and N, are both perpendicular to P, so both lines are perpendicular to P, then we can say that these lines are parallel to each other. Those two lines are parallel. All right, let's do an example. Determine which lines, if any, must be parallel in the diagram. So we've got line S is perpendicular to which ones? We've got line S is perpendicular to P and Q. All right, so line S is perpendicular. I'm going to write down what I know. S is perpendicular to P. S is perpendicular to Q. What else do I know? I see T is perpendicular to Q. You see that right there? T is perpendicular to Q. All right, so if T is perpendicular to Q and S is perpendicular to Q, what does that mean about S and T? Therefore, that's what those three dots means. Therefore, S is parallel to T. We just established that. That if it's perpendicular to the same line, then they must be parallel. All right, so we have that S is perpendicular to P. I don't see anything else that's given to us being perpendicular to P. However, I do see something else perpendicular to S. I see Q is perpendicular to S. So if we say that Q is perpendicular to S is perpendicular to Q, we established that earlier, but now I'm looking at this relationship between SQ and S and P. So if S is perpendicular to P and S is perpendicular to Q, what does that mean about P and Q? That means P and Q are perpendicular. Therefore, P is parallel to Q. Parallel rather. So if two lines are perpendicular to the same line, then they're parallel.